Welcome. We will talk today about Java. How many of you did the tutorials that were posted on the wiki? No. Okay. All right. So what we could do is we could go a little bit through the material which is there. So how many of you never had Java before? So I know you guys. Yeah, great. So maybe before we start, I kind of give you a little bit of intro to like what are the key elements which differentiate Java from maybe other programming languages. And I will I will need to move the camera a little bit. So we'll use the whiteboard. Yeah, hopefully that will work. All right, so let's do that. Okay, so Java came up. Oh crap! I don't have the pens. Yes, okay. Came up originally as a client-side language for the web. So some developers and some microsystems developed the language to be used in the browser. So the idea is that you have multiple operating systems. So you may have Mac OS, you can have Windows or Linux, and they will run a browser. And then inside the browser, you want the code to execute some functionality, right? So you will have some sort of runtime environment inside each browser, which runs on a native platform to execute some behavior. So how would you do that? Well, you have to isolate, and the operating system runs on a particular hardware, right? So this might be in the old days it was Motorola, it might be x86. You might run Linux on some ARM device and so on. So the hardware is kind of different. The operating systems are different. The browsers are kind of different. So you have to have something in common. So a single language. So if you have some sort of language in which you wrote a source code, that the common thing is kind of shared. So the same code can run on everything, right? So because of that, originally Java was an interpreted language, and it was interpreted on top of so-called Java virtual machine. So this common thing, which was used inside all those browsers, is called JVM, which stands for Java Virtual Machine, and it's basically like a virtual computer which interprets the instructions which are from the language, right, from the source code of the language. But it's very cumbersome to run the code based on the source code. So the source code in Java is some file name. So let's call it file.java. So what you want to do is you want to have like more machine readable format that can be interpreted in the browser, and it's more compact, and you can do some optimizations. So Java was and is compiled to so-called class file, and it usually retains the same name as the source. So if I have a file called file.java, I will end up having, after compiling it, I will end up with file.class, right? So for a single source file, I will have a single binary, so to speak, but the binary is a kind of binary for this JVM, for the virtual machine. And this binary then was transferred over the network, loaded by the browser, and kind of executed. Of course, software is more complex than a single source file, so you may have multiple files, and then you have multiple class files. We will show it a little bit later. So this bytecode was uploaded and then executed on top of JVM, interpreted in the browser, and did some behavior, right? This idea kind of never took off. What took off was to use the JVM on server side. So kind of paradoxically, it turned out that the language they developed for the web was actually best suited to run on a server, not on the browser, right? So now we have different servers. So I may have x86 server running Linux, and I may have maybe ARM, or I have something else running, some other hardware running Windows, and then on top I have this layer which is called JVM, and then I can run Java on top of that, right? But because most of the time we will be running on x86, right? What we can do is we can, so here we have the bytecode being downloaded on top of JVM. The JVM normally would interpret it, but interpretation is quite slow. Like it has to analyze what the kind of opcodes are, what they need to do, and then generate behavior on the platform to actually execute it, right? What would be better is, so you have this sort of interpretation stage, which interprets the bytecode and translates it to the actual instructions that need to run on the particular hardware. So what we can do is we can compile it into the actual hardware language on the fly to not do this interpretation stage. So we kind of get rid of that, right? So what happens in modern Java is you generate the bytecode, which is platform independent. Then a particular platform JVM takes it and compiles it into the native representation of the platform, into like x86 machine language, right? And we call it on-the-fly compilation, basically, right? The difficulty with this is that when you load the program on the server, it takes a little bit of time before everything is kind of hot, right? So on mobile devices, we will talk about it a little bit later. We have something called ahead-of-time compilation, right? So we have two types of compilation of the bytecode into the native code. On server side, we typically use x86, but on mobile, we typically use ARM, right? CPUs or maybe x86. So what happens is we have the bytecode being translated into machine code, and this process can happen when you load the program, then you wait a little bit, this compilation happens, and then you run it, or it can happen when you need it, right? So you run main function, we have to compile main, and then we don't compile anything else, we just start running it. And then if you need some other function, we compile it, right? So the second model is called just-in-time compilation, so JIT. The first model, where you load everything, compile everything, and then run, and you never compile things again because you pre-compiled everything, is called ahead-of-time compilation. So ahead of time, AOT, just in time or ahead of time, right? Of course, for programming in Java, it doesn't matter, but you have to understand that the Java source code gets translated into bytecode and then gets translated into machine code by the platform. And part of the job is done by the JVM, or the job is done by something else which does this job, right? So in case of Android, the interesting thing is that we use Java, but we actually don't use JVM. And that's kind of an interesting concept because I'm not sure if you are aware, but Sun Microsystems was acquired by Oracle, and Oracle made a big law case against Google for using Java, right? And the law case was that part of the JVM technology is copyrighted and protected by copyright by Oracle, right? But Google argument was that we actually don't use JVM, and on Android they don't use JVM. They have their own different way of interpreting the bytecode, and they don't use the .class files neither, because the .class files are a little bit bulky, and for the mobile platform they optimize it away into something called .dex. So they use the same language, they use exactly the same syntax, which is called Java, but beneath the syntax, everything else on Android is not Java, right? So Google was saying, we actually don't use Java. We only use, syntax of the language, which you cannot really copyright. All the technology which Oracle had were protected and not used by Google. So eventually, it took many years for the law case to settle, but and it was very important law case because it was about the interfaces for the native implementation, right? So Oracle was making the claim that you can copyright the interface to some proprietary implementation. And of course, in software development, if you allow that, then everything goes to hell, because, for example, you could never be able to use like print function, because C language already used a print function, and it's an interface to calling a function, right? It doesn't matter how it is done, right? It's just copyrighted this, right? And it would make software development like impossible if people would be able to copyright just the APIs. They can copyright the implementations, they can copyright how things are done, but not how things are named, because it sort of makes no sense. But for the lawyers, it was really difficult to understand the difference, and that's why the law case took very long time. You can read all about the law case online. So in any case, in normal Java, everything goes through JVM, and then we have the machine code beneath. So if I kind of go back to original file.java, you will see that I have some source code in a file, then I compile it. I will end up with the class file, which is usually called the same. And then I can run I can interpret or compile the binary, the bytecode into the binary and execute it on a particular platform. What happens when we have multiple files? Well, we would end up, if I have multiple source files, I would end up with multiple .class files, right? And then you have to move them around and ship them to the browser and so on. And of course, originally, because the language was designed for the web, transferring a lot of files is kind of cumbersome. So what do you do these days with JavaScript if it's split among multiple files? Well, you kind of minify it and compress it into a single JavaScript file, and you transfer one file. So the same is here. If you have multiple .class files, what you can do, you can zip them up into a single file. Let's call this file like B, okay? And then you kind of zip it, and instead of calling it .zip, you call it .jar, which stands for Java Archive, and you specify a single manifest file, which tells a little bit of metadata about what is inside, right? What sort of packages do we have, what sort of namespace we're operating in, and what is the main entry to this package, to this, it's not actually package, it's like this jar, right? We call them jars. So, jar in English means like a jar. So it's sort of like a single unit where you can pass around. So normally if you have an executable or if you have a library, you can distribute it as a single jar, right? That's why a lot of files which are distributed, which are written in Java, are kind of distributed as jars. So we will see how this works kind of later. Manually packing it up and specifying the manifest file and so on, it's possible, but it's a bit cumbersome. So we sort of do that using GUI tools, some integrated development environment to do that for us. But the concept is that you could do it manually as well in command line if you want to. And then you can sign it. So if you have this kind of a b.jar file, you can put some signature on it and you can check if it's valid, if it hasn't been tampered with, right? What's inside is the class files, and the class files need to be then compiled into the native code. So some implementations may differ, right? So Java has now two main implementations. One is maintained and provided by Oracle, and one is maintained and provided by Open Source Foundation, Apache Foundation, as an open source project. And of course, the open source one is free. It works fine. It has no deficiencies. Whereas the Oracle one is kind of the same, because they take the Apache one as a basis, and they may potentially patch some things faster, potentially, than the Apache one, right? So they actually charge for people using the official Oracle version, and people who don't care about this can use the open source one. So to program in Java, you have to have, so there is another term called, so one term is the JVM, which stands for Java Virtual Machine. The other one is SDK, so Software Development Kit, right? So Java is kind of distributed as a package called SDK, and they have two names. They have a name, kind of a marketing name, so Java 11 or Java 10 or Java 8. So they kind of have, let's say, there is one version of Java which is called Java 8, and there is like a versioning system which is based on major minor kind of version numbers. So the Java 8 is an equivalent of SDK version 1.8, right? It kind of happens that this second thing always matches the latest one, right? So Java 2, original Java was Java 1, 1.0. Java 2, the new release of the Java which introduced generics and other things, was actually called 1.2, right? So Java 2 was not actually 2.0, was 1.2. And then we had Java 3, Java 4, blah, 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 up to Java 11 or 12 at the moment. There is a lot of new things which happened in Java 8, and they introduced some new features in Java 11 which allows you to have like a interpreter running in your shell, so you can kind of interactively execute Java instructions, but we will not go there. So all the tutorials that you find for the early versions of Java are kind of the same. Everything kind of works the same because Java all the way from 1.11 is backwards compatible to 1.0. So anything kind of written for that 1.0 still works in the latest one, with some caveats, because some things have been deprecated. So if you try to compile it again, it will complain. But if you try to run it, it will kind of run, right? If you already have it compiled into the class file. But if you try to compile some new stuff now, I mean some old stuff using the new compiler, it will say you're using very old APIs, you have to use the new versions because the old ones have been deprecated. Okay, so that sort of is a big picture. So is Java an interpreted language or is it a compiled language? What would you call it? Yep. So All right. So yeah, let's continue. I give you eating. You can eat. It's fine. You can continue having a break. I will just continue talking. We got some basic things going. So let's talk a little bit about the language itself. So if I go to, yes, I have to go back. So if I go NTNU test, not the class file. Oh crap, I deleted it. Okay, so we type it again. NTNU IMT blah 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 test. Yeah, that's why you should use version control, and that's why you should always commit your changes. I kind of recalled the command and I kind of recalled the wrong thing without noticing. So yeah, anyway, it wasn't a huge loss, right? So that's a valuable lesson. All right, so we have our package. We have our public class. We called it test because we're inside the test. And then we have some, some stuff, right? How many main functions can you have in a program, in a C program? Well, only one, right? So if you have C source code, you generally have one file somewhere which has the main function. In Java, you can have as many main functions as you need or as you want in each of the classes, right? So if I have a class called test, I can have a main function in class called test. And so let's try that. So I have a class here called test, and I will have a public static void main string string arguments which system out print line hello from test, right?
Maybe actually name the test of Java.
Which one?
The file name.
Oh yeah, that's right. Yeah, that's right. I will have to do that. So move NTNU IMT test to NTNU IMT test. Does it matter on a file insensitive, case insensitive file system? Let's try out. So if I try to compile it, yeah, let's compile it the kind of cheap way. Yeah, again, I forgot the C. I should not be using Java. Yeah, it does matter even on the case insensitive file system. So be proper and let's rename it. Most file systems are case sensitive, but some are still case insensitive, and a Mac by default uses case insensitive file system. Okay, so if I try to do that now, no help. And if I try to place it destination classes, it will work, which is great. So what I can do is I can copy NTNU IMT test into NTNU yeah, let's put so we have a kind of a top name which is NTNU, and then we have slash or dot into IMT. We can put another class called test inside here. So if I show you, I have class called ntnu.test, and I have class called ntnu.imt3673.test, right? I have two classes called test, which both have a main function. So I will quit that. I will go vim ntnu test this one, and I will say this hello is from outside ntnu.test, right? So now if I kind of compile it again, so where is my compiling thing here? And I say compile everything which is from within the NTNU. I will check. So inside classes we should have NTNU. We should have one file here and second file here. We don't, and the reason is, do you know why? What we forgot to change for this one? We forgot to change the package, because now this file lives inside package called NTNU, not inside package called ntnu.imt, right? So we will save it, we will compile it again, we will check, and inside NTNU, again, it didn't work. So now it doesn't complain about anything, but it's suspiciously quiet. So let's double check it. Great, we have a class file in the NTNU package, and we have a test class inside the IMT package. So now, having those two, if I go classes and I say Java, and I run the main from the test which is inside the IMT package, it says hello from test. And if I run the main from here, it says hello from outside ntnu.test, right? So I can have multiple main functions, and you have to tell which one you want to run when you're running them. So you have to tell where is the entry point, right? It's similar in Android. In Android, you can have multiple entry points to your app. Your app can start from different places and do different things, and you specify again in a manifest file what are those places. So in here we have kind of two entry points, right? In fact, what happens often is you developing your software, you're developing something, you will have an app doing something, but you will have multiple class files all over the place. And for testing purposes, sometimes you want to run something from within one class to just test that this class does what you think it does, right? So you, when you're developing, what may happen is you might be developing some logic here. Let me then, yeah, because we are one level 2. Yeah, so you're developing the behavior of the class here, and you don't need a main function for this class, but out of usefulness, often you have kind of a debugging main function which you can run just to test or play with some of the methods that you're using and you're developing right now, right? It will not be entry point to your application. It's just an entry point for just temporary testing that you want to do. So it's kind of a common practice to do that while you're developing your class. So what is the class? How many of you never had object-oriented programming? That should have no hands, right? So in object-oriented programming, you have a concept of the type, and you have a concept of the instance of that type. Is that correct? So you're defining what a particular type is, and you're doing it by some member attributes. So you're saying I have a class. Yeah, let's because test is a bit of a stupid name. So let's have another class inside my source file called person, and I now have two classes. One called test, which is a public class, and another class called person, which is not public. What would happen if I say public? Well, it would violate the rule that all public classes have to be in a file called classname.java, right? So the compiler would complain. But hidden classes, which are only visible inside the package, can be placed in other files, right? Because the class person is only visible in this package, because I haven't set public, means it's a kind of a private class which is visible only within the within the IMT3673 package, right? It can be in the same file. You could also have a class which is inside another class, which is only visible inside that class, right? I could have another non-public class which is inside my test class. And that is called a private class because the types are embedded. Like the type which is inside another type is only visible in that type. It's not kind of visible or accessible from outside, right? But in this case, let's have a private class which is visible in the package. And we will have, we can have a name and we can have an age, right? And those are attributes, right? So now I have a type called person. And what I can do is I can say in my main function, I can say I have a person A, right? So as in C or in most languages, the type comes before the variable names. The variable names are, you know, initialized or not initialized. This one is not initialized variable, which kind of is of type person but doesn't hold anything yet. And I have a type which says, okay, type person has two attributes, no methods, right? So it's kind of like a struct. If you're familiar with C, that would be like a struct. In Java, you don't have structs. So you can have struct by doing this, right? If you want a struct, you just have a class with no methods. What else is happening here? Object-oriented languages have inheritance, right? So some things inherit from other things. And inheritance is kind of a good kind of mechanism for encapsulating behavior. And in Java, it happens that everything extends a base class type, which is called object, right? So in C++, that's not the case. If I said class person, it will be just class person. It doesn't extend anything. But in Java, even though I'm not saying it, it extends object type, right? And then what's useful is, so let's use Java 8. What's really good is to have API opened for all the types that we use in Java, right? Java is a very large language in terms of packages and types, and it's really difficult to remember everything. So you don't memorize all of this. You basically have this open and you can browse. So we can go, as you see, everything in Java lives in the packages, right? And it's prefixed with Java, and then it's too small. So everything is kind of inside a package, and all the basic things are inside package called java.lang. And if I'm using basic things, so let's see what's inside java.lang. Oh, come on, work. So we have some types in here. We have some classes which are available. And we have things like system, you see? So the system class contains several useful class fields and methods. And I'm using it because I'm using a class field called out on side a system, but I didn't say java.lang.system. So anything inside java.lang, it's by default already visible, right? Anything else you have to say where it is, but that's the package which is kind of an exception to the rule. And all those things which are here are visible without me specifying the fully qualified names. So that's what I'm doing with system. So system actually is java.lang.system, right? But I don't have to say it. Like if I say it, it's fine, it's legal, and you can do that, but you don't do that because you don't have to, and it's shorter if you don't do that. So it means I'm using java.lang.system, which is this guy. And this guy, if you click on it, you see, oh, it has a lot of fields. out is one of the fields, and it's a stream, right? So it's an output stream. So let's not talk about it for a moment, because what we wanted to talk about is the object. So let's have this object type which everybody extends. So you see it lives inside java.lang, and it has been since JDK 1.0, and it has some methods. So one of the methods is clone. It has an equality check. It has kind of a method called getClass, and so on. So even though I haven't specified any methods on my person class, this class already has all those methods because it inherits all those methods from the object, right? So I can say .clone, and it is a valid method on my person because it inherited it from the object class, right? Make sense? All right, any questions? Okay, so this is a very useful resource, right? Browsing the types and checking what things are, right? So Java is object-oriented. We have inheritance. Class person inherits from class object. Okay, we have declared that we have a field called name, and it's a string. Well, you can guess it's a string, right? So let's have a look. I don't know why this clicking on this doesn't work. But anyway, we can go here and we can find the type java.lang.string. And again, it's a type which has some methods. You know, for string manipulation, it has a constructor, and it has kind of methods, for example, length, which returns how long the string is, right? Or it has a method called split, which allows you to split the string according to some pattern that you want. It has a method called substring, which means I can say from that string, just give me a substring which starts at that position, right? And so on. And two lowercase, which, you know, returns you a string, which is the lowercase version of the string you gave it, right? And you can check all those things here, right? Will you remember all those things? Well, you will not remember everything, but once you're using it, you will remember most of the things, right? So while you're using the language, you will kind of have it in the working memory, and you don't need to look up everything, but you know, you don't need to memorize it. It's a kind of a useful resource to have open and use. So now we have another one which says int. If you program in any other language, you probably guess it's an integer, right? But if you try to find java.lang.int, you will not find it, right? Well, weird, right? So we could also say integer age, right? And that will work. Well, it will work with the caveat that I have to have a different name for the field. I cannot have, you know, the same field declared twice. So that works, and we can find integer, right? So if I go into Java, java.lang.integer, which we will find if we go one step back. Yes, it's here, and it's again a type which extends object, but it also extends java.lang number, and also extends Java. I mean, that's the type which we are currently having. So it inherits from object, but it also inherits from a number, right? So it's like, as I told you, it's a way of extending the functionality, right? So we have an abstract type numbers, which can be a float or can be an integer, and then integer is kind of a subclass of the number. And it has a lot of methods as well. And you can use those methods if you did this, right? So this field would be of an object-oriented type, which you can call a lot of methods on. This one is a primitive type, which means you cannot call any methods on it, right? It's a primitive type which is not an object. It actually is an integer, right? This one is an object, and name is an object, but age is not an object. Age is a primitive type. It's just a number, right? Why do we have that? Well, we have that because it's much faster to operate on primitive types than it's on numbers, right? So for example, if I go to if I go to length, we have to find the number again. So if I go to a number, you will see I have like to add two numbers, I would have to get a value out of the actual object, do the addition, and convert it back to that object, right? So to add two numbers, I have to do three operations. I have to kind of convert the object to a number, convert the other object to a number, add them, and then convert the resulting number into an object, right? And I have to do the memory allocations and create the new object, which is the result, and so on and so forth, right? If I want to add two primitive types, I do nothing, I just add them and the result is a primitive type. So it's much simpler and much faster. It's depending on the implementation, it may be up to 20 times faster to do it this way than the object-oriented way, right? So for performance optimization reasons, the designers of the language distinguish between primitive types and object types. And how many primitive types we have? Well, so we have int, we have float, and we have boolean, right? And they all have equivalent object-oriented type. And when you use what? Well, most of the time you use the primitive types until you need to use the object-oriented types, right? When do you need to use object-oriented types? For example, if you have a container and you need to store instances of objects, then you have to convert the primitive types to object type because you cannot store primitive types. So can you have a container for primitive types? Yes, you can. You can have an array, right? So I can have, for example, an int array of, I don't know, shoe sizes. So we should use the camel case, or I can have an array of people. So I can have person, and I can have, say, those are this person children, right? So there is a field called children, and it's a primitive array which contains objects, right? So you can have container which is a primitive array which contains objects or contains primitive types. And you can have object-oriented container like a list or array. So I can have an array which is an object-oriented array, and it can contain person, which is like a specialization of the generic array, which is like children too. Or I can have the primitive version. The primitive versions are faster but less flexible. The object-oriented equivalents are more flexible, but they kind of are a little bit more costly, right? Should you think about it? Well, you actually have to think about it, but you should not be thinking about it in terms of optimizing it, right? You should use what's easiest for use, right? So when you're declaring age of the person, what you planning to do with this age? Are you planning to store it in some container which is object-oriented, or are you just gonna compare it to some threshold values or add some things to it, right? You know, in most use cases, the age is just a float or integer. So you would use the primitive type. So you kind of choose whether you're using the primitive or the object-oriented equivalent based on the what kind of makes sense in the given context. There is no primitive string. Strings are always objects, but they are treated specially by the JVM. And then for the numbers, if you're doing calculations, you use floats, like you just say float. And if you're doing some, integer arithmetic, you use int. And then for Boolean logic, you use bool, right? Boolean, actually. So those are the typical primitive types that you would use. If you want extended accuracy of the floating point operations, there is something called double. So double is another type, which is a floating point type, which has the, it's bigger, it's longer. It has capacity to store, more bits of the floating point. If you want to store something shorter than the integer, you have a byte. So, it's an equivalent of the byte. Most architectures will, allocate 4 bytes anyway for this type. So you're not saving much. And then you also have char. So char is a primitive type for a character, right? For a single character of a string. So those are kind of your typical primitive types that you use as you would use them in JavaScript. You don't really have types, but it's kind of the same. And in in C or C++. You may sometimes opt to use the object-oriented ones because you have a reason to do that. You can store primitive types in an object-oriented array by a process called boxing. So sometimes what you want, let's say we have a case where so let me do, I have a list of integers, right? And that's our list. So I could have right. So the list it kind of complains that it doesn't know what list is, right? So then you have to go here and you kind of say list. So abstract list, yeah, it should have a search, yeah, yada yada yada. You go to the list, and you see that a list is an interface inside java.util, right? So to use it, what I have to say now in my class is I have to say import java util list. Okay, and if I do that, then this interface will be visible, and I can use it to specify my member field. Sometimes, yeah, and it's in the wrong place because you have, so the structure of the source file is the package is the very first thing you have to have, and then you have the list of imports, and then once you finish, you can start declaring types. So you can declare your classes. You cannot introduce new imports like inside a particular namespace. So you say import java util list. So that works fine. You could, like, if you want to import a lot of things from java.util, you could say I want everything from java.util, right? So you could do this, but that's kind of frowned upon. Like, it's legal, you can do that, but it's a bad programming practice to do that because you're importing everything that you don't need, right? I currently only need one type, and if you do this, it's not clear what you're actually using, right? But if I do this, you communicate to whoever is reading the source code that you're using this interface from this package, and it's very obvious, right? So it's a little bit tedious if you have multiple things that you have to import and they are from the same package, because you end up saying, I can import java util array as well, and I probably have to say import java util array list, right? So obviously doing it manually is tedious, but IDE will do it for you, right? So the IDE will scan the source code, will check which imports you're using, which one you're not using, and they will manage that for you, and you do that explicitly, right? So you typically don't say the star thing. Yeah, so let's have those two. And now I can use it. So I can, for example, say I can say my person a list equals new array list, and my a I can say put one. Yeah, let's go into a list. So the interface list has some methods. We need to find a method which is to add an element, and the method is called add, right? So the method is called add, and it returns if it worked out or not, and it has to have the same type as the specialization which we used for the list. So it means I've used integer, so it's not called put, it's called add, and I cannot add anything. I cannot say mama, right? That wouldn't work because it's a string, it's not an integer. So I can only new add integer. So I have to say new integer, for example, 1, right? So that would work. So let's see what's the complaining is. Of course, because we have to say list. Okay. And we have to say here that it's integer. And it probably complains, just let me check. Yeah, so it complains that the constructor which I'm using, which passes the primitive type to the integer, has been deprecated. You're doing it different way now. And also it complains that I'm kind of saying a.list is a new array list, but I haven't initialized a, right? So it knows that a is a like empty pointer which hasn't been initialized, so it kind of complains. So I would have to say new person, right? So this the previous line was declaring a variable called a, but not initializing it. This line declares the variable and initializes it at the same time, and it initializes it with the new instance of the person, right? And then I can initialize the this member field to be a list of integers. So there is a little bit of magic happening here because I'm using an interface here, and I'm using a concrete implementation of that interface to actually instantiate it. It's a common object-oriented pattern where you're hiding how things are implemented by declaring the type to be an interface to something that always works the same way but can be implemented multiple ways, right? A list can be a hash list, like linked list, or it can be an array list. So depending what I want to optimize for. So for example, adding new elements and removing elements in a linked list is very trivial because it's just adding a pointer or changing the pointers, right? If you have an array list and you want to remove the middle element, what you have to do is you have to copy the beginning, copy the end, kind of into a new array, and then you have a new version if you remove the middle element, right? Removing an element from a linked list is very trivial. But, you know, from the API level, you're saying, remove me an element from the list, right? It's always the same. How it is done depends on what you're using it for. So if you have a lot of removals in the middle, it's very stupid to use an array list, right? But if you're only adding things and you're kind of processing the list, it's actually faster with the array backed list than with the linked list. So Java provides different implementations for the list, and you can use the one which fits the algorithms better, right? So I'm using an array list, which means it's sort of like a list. It's not like a vector in C++, which can kind of grow, but it's not very optimized to be removing stuff in the middle because it's backed by an array. So the implementation uses like a native array to keep track of your list, right? So this line adds a new item to my list, but if I set this, it would also work. but it doesn't store the primitive integer in my kind of container. It actually calls the previous line. So it generates a new integer object based on the primitive type that I passed it, right? And this process is called boxing, right? So boxing and unboxing means you take a primitive type, you wrap it inside an object, and then you use it as an object. And then unboxing means you take the object, you extract the primitive type out of it, and you discard it, and you use the primitive type. So in here, we're doing like a syntactic trick where I'm saying put 1 into my integer list, but actually it's not happening. What is happening, 1 is converted to an object and then it's put inside the container, right? Because it has to be an integer. It has to be of this type, not of the primitive int type. Make sense? All right, so we covered quite a number of things already. So let's put some methods. Let's put a method here. So let's say, let's have a method called string getName. And unlike C++, you don't have header files. You only have source code. You don't declare what the signatures are. You implement stuff where you're declaring the type, right? So I'm declaring that type person and what fields it has and what method it has. And I'm saying what the methods do here. I don't have 2 files to do that. So I can say something, right? I don't need to implement it. I'm just kind of explaining the concept here. So this method will do something, right? This method is an instance method, right? So for example, if I come here and say, yeah, let's rename the person to be P because it just bugs me to be. Yeah, I have this disorder of order. So the person P, I can say getName, right? Now, and this method will return me whatever I said it should return, right? So if I say return Mariusz, it will return Mariusz, right? So it will work. And it will return Mariusz, and it will discard it because I'm not doing anything with it. But I could say system out println, right? System out println getName, P getName, and it will work, right? So this is fine. Can I say person.getName? Can I do that? Yep.
I would say no, but it's not a static thing. So static method.
So what does it mean?
It means that you have to instantiate an object that the person can't before you can call the method. If you have a static method, you can actually call the method without first using the keyword new.
Yeah. Yeah, that's right. So the difference is this method is being called on behalf of the instance, which is P, right? So P becomes the receiver of this method, and P executes that method. It's not the class which executes the method, it's the instance which executes the method. Whereas when I do person.getName, I don't have any instance. I only have the type. Which means there is no receiver. Nobody can get this method executed, right? I have to have an instance. Same if I said this. If I said getName, again, like the receiver of this method is the instance which doesn't exist. There is no object which is receiving this message, right? So it cannot be executed. So if you have a need to execute a function without the receiving instance, then you have to have so-called static function, static method. So if I have a static method called, I can also have static method called string getName2, right? And I can return another name. Then what I can do is I can call this line wouldn't work, wouldn't compile, because the compiler would say, to whom you sending this get name method, right? Are you sending it to whom exactly? So you would have to say, I'm sending it to person, and person is a type, is this type that we have here, and this method would be executed, right? And what's the difference between those two methods? Well, there is no difference, right? There is a very tiny small difference. In this method, I have, in scope of this method, there is an object which I can do stuff with. And this object is called this, right? I have, if I do this p.getName, this is p, right? So I can do stuff, I can extract stuff, I can call other methods, and I can do things on p. This method doesn't have that, right? So that's the only difference. Like, otherwise they look almost identical, right? But there is no this in scope of this method. There is this in here, right? So I can say this dot get age if I had another instance method called int get age, and it says return, yeah, we lost the age. No, did we lose the age? Yes, we lost the age. So I have to declare int which is age, right? So if I say return, so one difference between C++ is I don't need semicolons at the end of those declarations here. At the end of the class declaration and at the end of the method declarations, there is no semicolon. So I say return age, right? And if you are a purist, and some coding conventions kind of enforce this, you would say this.h, right? But it's the same. Syntactically, it's the same thing. Some people skip it. I tend to put it in because it reminds me that it's about the instance, right? It's visible, it's highlighted, and I know, okay, it's the instance field which I'm using. Because you may have you know, a lot of variables here, and you're using different variables, and some of them are attributes of your class, some of them are not, right? In this particular case, it makes no difference because it's as readable as it gets, with this or without this, right? But if the method is more complex, some variables are the method variables, and some are instance variables. And then if you prefix the instance variables with this, it's very clear. And what also it allows you to do, it allows you to do something like this. It allows you to say, I have age which is 10, right? It might be a bad programming practice, but it would work. It would compile, and it would work as expected because it would use this one for the return, not this one, right? So you may kind of use this to differentiate some temporal variables which you have in the method and the field variables that you have in the instance of the class, right? So I tend to use this thing here, even though you don't have to use it. Although in this case, you would have to use it, because if you didn't, what would happen? You would return 10, right? If I didn't say this.h, I would return 10. But if I said this.h, I will return whatever that is, right? Right, so what else is left with the hello world? So static, now you know what it means. It means that it's an instance method on top of the test class. So it doesn't need an instance, right? What does it mean is that it runs like just without any instance. So that's what I was saying when we called get name, right? We try to call get name in here, but the compiler would say there is no instance. You cannot call an instance variable on that type, right? So then if we try to call a type function called getName2, which is a static one, it would say, yeah, that's fine, you can kind of call it, but you know, test class doesn't have any static variables, any static method called getName2, and it tries to run this method on top of the enclosing type, right? So it tries to find a method called getName2 on one of the static methods on this type. And if we had one, it would run it. But because we don't, we have to be fully qualified. So we have to say person, right? We have to say the type and and dot, and then it will be fine, right? Then it would run the static version of this method on the person type. So the final thing here, there are two more things. So one is the signature. The signature uses the string array of arguments, and what it basically is, if you're calling this thing, so if I'm saying Java whatever the package ntnu.i whatever that was test, and then I put some parameters here, those parameters will be passed into my main as a text items in this array, right? So if I said Java into a test I don't know, mama, then the parameter 0 would be this, and parameter 1 of this array would be this token, right? And I can check, I can say what is the, I can ask, I can say args length, and it will tell me 2. In the other case, if I call it just like this, it would say 1, right? Because I only have one thing. And then you can access them by args index, so 0 and so on. Java uses 0-based indexing of arrays, so you can read it like this. Do you need to call it args? Of course not. So that's just a variable name. You can call it whatever you want, right? But this is required, and main has to be called main. It has to return nothing, and it has to be a static function. What would happen if you so if I delete those two things and I have non-static main? Can I have a non-static main? So let's delete that. Let's check. So you see I don't have any red things on the side, and if I try to compile it, it would compile, right? But what does it mean? Would I be able to run it? No. So I can compile it. It's the main is not any special forbidden name for a method. You can have a non-static main, but it's kind of pointless and bad practice because you're confusing what is it for, right? The point of main is that it's an entry point to run something and to call it like this, which I did in command line. If you have a method, instance method main, is like, why would you have it? And you say, well, I have a type, I like in a different file, you could have, let's say I have a public class called application or app, right? And I will have some instances, and then I want to say, like in my main, I want to kind of instantiate it. So I would like to say I have an app called app, which is a new app, right? And then I would say app.main, right? And that would be perfectly legitimate, right? To have an instance main for this type of pattern. But again, it would be a bad practice because it is confusing, like main is main, right? So if you need this pattern, what happens, most people would say, okay, we will have main with capital M, right? To differentiate it, that it is sort of different to the normal main, that you are doing something like, or you could call it run, right? You could call it run up or something differently. And you could use this pattern, but yeah.
So what version would be the capitalized?
Well, you would have to call, you would have to make the instance main capitalized, right? To differentiate it from the public static normal main thing. So the static one, the normal one for running stuff is always small letter. And as I said, it's a little bit unusual to call methods with capital letters because most methods in Java, like if you browse the API, right? So if you're browsing the methods, you see they always start with small letter. So if you're naming your methods with capital letter, you kind of odd, right? But it is an odd case. Like for this particular case, sometimes it happens, right? And the types, all the types, like which you see here, always start with capital letter. right, in the libraries. So that's why we start our types with capital letters as well. It's not forbidden to start it with a small a. You can have types, but it's a little bit confusing because the small letter types are dedicated to primitive types, right? As you've noticed, only the primitive types like void. Void is also a primitive type. Start with a small letter first. So we almost done. There is one tiny thing. Yeah, we are a little bit over time. So it's this out thing. So this is a static field which I can access without having an instance. So same as we have static methods, we can have static fields. So I cannot say, for example, here, I cannot say person.h because, let me do this. So I cannot say person.h because there is no instance. I can say p.h, but not person.h, right? But if I changed it to static, right? H, and I changed it to static, what would that change? Yeah?
Yeah, well, now you can access it.
You can do this.
Does it still work to do the second way?
It will still work to do the second one, but again, it's a frown upon.
Yeah,
bad practice because you're confusing the instance with the class, right? You can do this and it will work, but it's a bad practice. And why it is bad practice? Yeah.
Well, then it's hard to tell if it's a static variable or a different one.
Yeah, and why it is confusing?
You don't know if you have to instantiate the class with the access variable.
Yeah, and what else?
I can't think of anything right now. Might have a different value.
Exactly. So if I did it as static and I have two variables called person, there are two ages. But with the static one, there is always only one age because everybody, all the instances will only have one age because it's a shared among all instances because it's a type level thing, right? So if you want a counter which is shared among all your instances, for example, you declare it static, and then whoever increments it, it's visible. You know, everybody is like a global variable kind of thing. But if it's not static, then you have multiple copies. So each instance has a different age, right? So out is static, and then it calls a method which basically puts this string into a stream, right? So the input-output in Java is done using object-oriented streams, and we will use them for input-output from Android to get resources from the web, for example, if you're doing networking. So streams is a bit of a complex topic. We will cover it in a lecture later on, but that's how you decipher this last final bit of the hello world. Right, so we kind of rushed through the basics, but I hope you get kind of a picture of how things fit and how they work. Obviously, you don't know Java yet, so I do encourage you to check the materials which we posted on the wiki. And on the next session, if you have any questions, bring them in and we can discuss it, right? So for Tuesday's session, if you have any Java questions, don't hesitate to just come or put the issue in the issue tracker and we will discuss it first, all right? So thank you very much.